Hey everyone, welcome back. In this video tutorial, I'm gonna start working on a new proximity and ambient light sensor, that is VCNL4010. Now to gain more knowledge about this sensor and to know more about this sensor, what it is, let's have a look over the website we are referring, that's webcontroleverything.com, and here we have to search for the required sensor, that is VCNL4010. So we have, it's a proximity and ambient light sensor with infrared emitter, and you can see some of its features, and you can also purchase it from here as you see. Now I'm gonna interface the sensor VCNL4010 with the particle photon, and for that I require a code. So go to resource tab, and here comes the particle code sample we are talking about. Now you can download the particle code sample as a zip file from here. That's correct. Also, you can have the privilege to download the code from github.com, and the repository there is Control Everything Community. Well, we require some hardware connections so that we can have a proper setup to show what the sensor looks like. Let's have it. Now coming to the hardware connections part, first requirement is of a sensor, that is proximity and ambient light sensor VCNL4010. Now we want to interface it with the particle photon, and here it is. The next job is to make a connection among the particle photon and the sensor, and we need an I2C shield. It is available on the website controleverything.com, and the reason we are using is to make connections with other I2C devices, and that job should be a lot easier. That's why we are using it. Now this is a connecting cable. This is the binding factor which will connect the sensor and the I2C shield, and it's very useful in that kind of part. Now while making this connection, we have to be sure that the brown wire of the cable should be connected to the ground terminal of the sensor and for the I2C shield also. So we are done with this part. Now the last part is to power up. So we require a micro USB cable just like this, and gently put it over the power jack. So we are done with the connections part. Now we require a particle code so that we can interface and show the working of this sensor. So we have to show the interfacing with the particle photon, and so for that we require the particle code. To get the particle, log in to github.com, and here we have to search for the repository, that is Control Everything Community. Here it is, and log in here, and here search for the sensor, that is VCNL4010, and it's a proximity and ambient light sensor, and this is the particle code we are looking forward. Let's have a look over the instructions we need to follow for pursuing of this code. As you can see, we have to log into particle photon and set up the device, and this link docs.particle.io, it will help us to set up the connection. As you can see, we can connect our device over the USB, operating system, and the relevant commands are there. Please note it down carefully. The next part is to download or git pull the code, and we have to copy the code on the online ID, and build.particle is the online ID. As you can see here, we can have the code, we can paste here, and we can name it, and we can save it. The last part, but not the least, we have to verify and flash the code on the particle photon, and the code output will be displayed on the dashboard.particle user logs. Now here comes the user logs. As you can see here, the relevant result will be shown. So this is how a particle code works. Now get back to the particle code so that I can explain it better. As you can see, it's a .in extension file. Now in the relevant code, the first thing you notice that we have included application.h and spark wiring I2C.h header files, and we have defined the address of the sensor, that is 0x13. Now we have created some variables, as you can see, initialized them, and here also. Now in the void setup function, we have initialized I2C communication as master along with serial communication with baud rate equal to 9600. Now in the writing section part, we are sending commands to the sensor, and we have selected the command register having address 0x80, and the command here we have sent is enable ALS and proximity measurement LP oscillator, and the command for that is 0xFF. The second command we are sending is to select proximity rate register having address 0x82, and we have setting 1.95 proximity measurements per second, and the command for that is 0x00. The last command is to select ambient light rate register having address 0x84, and we are sending continuous conversion mode ambient light rate 2 samples per second having the address of, and the command address is 0x90. So we are done with the writing commands. Now we want to get the data back from the sensor, that's the reading part. In the void loop function, we are, as you can see, selecting data from the register 0x It's a 133 decimal, as you can see, and we are requesting 4 bytes of data for luminance and proximity. We are pulling the data, and after pulling the data we are converting the data for proximity and luminance according to the conventions and the formulas we are used to be in the data sheet for VCNL4010. At the very end of our code, we have the output data to be displayed on the screen. As you can see, it's ambient light luminance along with the proximity of the device. So as you can see, it's a very generalized and simple code. You can go through if you have any concerns. Now what we require is to show the working. So let's have it. Now in the working environment, the first job is to copy this entire particle code, as you can see on my screen. Now open up the build terminal as we have discussed earlier, and here we have to create a new file and save the code there. Now VCNL, as you can see, is the sensor name, and here we are pasting the code and saving it. Now compile and verify the code. It's done. Now flash the code. While flashing the code, we have to check for the magenta flash, which will confirm that code is good to go, and we have that flash. It's a magenta flash, and the successful notification of the flash is down at the bottom of the code here. Now let's open up the dashboard link so that we can have the output to be displayed on the screen as for the proximity and ambient light luminance. Yes, here we go. As you can see, it's almost stable as there is no interference regarding the proximity and the ambient light. Now when I place some object over the sensor, as you can see, there is a change in ambient light luminance and the proximity. Now when I bring closer to the sensor the object, there is a very much change regarding the ambient light luminance. It's decreasing too much and proximity is increasing. The proximity is infrared, as you can see. Now instead of that, if I bring some light source near the sensor, you can see the increase in the ambient light luminance along with the proximity. Now if I bring closer the light source, you can easily see the changes in ambient light luminance and the proximity of the device. Yeah, there you go. So this is how the sensor works. Let's have a look over the applications and the benefits of this sensor. The VCNL4010 is a fully integrated proximity and ambient light sensor. Fully integrated means that the infrared emitter is included in the package. It has 16-bit resolution. It includes a signal processing IC and features standard I2C communication interface. It features an interrupt function. Due to these features, it's applicable for a lot of applications such as proximity sensor for mobile devices, example smartphones, touch phones, PDA, GPS for touchscreen locking, power saving, etc. Integrated ambient light function for display, keypad, control, contrast and dimming of mobile devices. Proximity optical switches for consumer computing and industrial devices and displays, and a lot many. Now you can purchase the sensor from the website controleverything.com, as you can see, and you can have the code from the resource tab. After that you can download it as a zip file. You can also have the code from github.com and the repository there is Control Everything community. In the end, I would just like to make it clear that in case if you have any further queries, you can reach us on controleverything.com, and be sure to post your comments on the community page. For blogs, articles which are relevant to this sensor, this video, you can have a look over instructables.com, and to subscribe more video tutorials like this, go to our YouTube channel. In the end, again, I wish I hope you enjoyed this video and have a good one yourself. Thanks a lot for watching.